Hello and welcome to the presentation of our paper on adapting forests to an uncertain climate, a critical technology review. My name is Max Krüger. I'm a postdoc researcher at the University of Siegen in Germany at the Department of Information Systems and New Media. And I will be presenting this paper today here from my kitchen. But before I do that, I briefly want to introduce my co-authors with whom I wrote this paper. They are Felix Karros. He's also a researcher at the University of Siegen. Maximilian Brandt, who's a forester by training and works for the forestry department at the canton of Bern in Switzerland, and Deborah de Castro-Leal, who's also a postdoc researcher at the University of Siegen. What you see here in these two pictures illustrates the situation of forests in Germany right now. Both show areas that were just very briefly before populated by dense spruce forests, which were then also very recently cut down as a result of the effects of climate change. Spruce trees were just a few years ago the dominant economic tree in Germany, but they suffer and still suffer heavily from hotter and drier climate and warmer winters brought on by the climate catastrophe. This made them susceptible to bark beetles, which then killed thousands of hectares of spruce across the country. As a result, huge areas that were covered in dense spruce forests are now empty, as these two pictures show. It is thus clear that something needs to be done, that forests and forestry practice as they have been practiced until now need to be adapted to climate change. This is what our research and this paper focus on. So these economic spruce plantations were planted for creating fast-growing yet durable and straight timber. It was planted across very large areas in Germany and often in monocultural stands. As you can see here in this picture, they were planted in neat rows with streets in between where the heavy harvesting machinery would drive. And all of this was done under the assumption of a rather stable climate. The average harvest time for such a tree is between 50 and 100 years. So the people who planted them were under the impression that the climate would be stable enough to support these trees for up to 100 years. But now, with thousands of hectares of forests dying within just 5 years, it is very clear to most people that this does not work anymore. Neither can anybody pretend that monocultural spruce plantations make great forests for a future, nor that the climate is stable. So if this old model does not work anymore, the question is, what does work? And that question is very difficult to answer. The climate catastrophe here creates deep uncertainty regarding the future of the climate and thereby also the future of forests. Of course, there are many models of possible futures in the climate catastrophe, for example, such as those offered by the report of the Intergovernmental Panel on Climate Change, which try to create outlooks of how likely a specific temperature rise is and what the consequences of such a temperature rise would be globally. That's where numbers come from, such as the 1.5 degree or models such as RCP 4.5 or RCP 8.5. But these models are not sufficient to anticipate what effects such a climate change would have on a specific site of forest in a very local environment. The long-term behavior of complex socio-ecological systems, which is what forests are, is unpredictable. Foresters would not only have to know what the climate would look like in a specific area, but also what other plants, animals, or fungi would exist in that area, which changes with the climate, but also by globalization, which introduces new species. They would have to know what markets look like for forestry products, which technology exists for processing and so forth, which allow them to create different products. And all of that they would have to know for a time frame of at least 100 years, as trees live, of course, much longer than 100 years. But let's say 100 years is the harvest time, at least for spruce. This is impossible to know. Such a prediction for 100 years or more is impossible to make. And yet foresters have to make decisions today and somehow deal with this uncertainty. How they do that and how such processes can be supported with digital technology is the focus of a research project we are working on. As part of that project, we are conducting a systematic technology review of forestry-related applications. We have so far identified about 270 applications, and for the sake of this paper, we have selected 2 of them that specifically deal with uncertainty in climate adaptation, but they do that in very different ways. Our paper then presents a critical technology review of these 2 applications. The first application that we would like to present and review here is called WoodsApp. It's developed by a private company, and it is made for foresters and forest owners who wants to support. The application wants to support cooperation between them. It has many functions, but for today, for the sake of this presentation, the most important one is a warning system of vitality loss of plants, which can indicate drought, bark beetle infestation, or other problems. For this, it uses satellite imagery of the Sentinel-2 satellite, which is updated weekly. In this picture, then, you see a site where vitality loss is indicated in pink. Foresters or forest owners would use this application to look at their forests and then see if there's any pink areas, if pink areas are growing, and then based on that, make decisions if they have to intervene and what to do. The second one is called Waldinfo, which translates to forest information. It's developed by the state of North Rhine-Westphalia in Germany, and it's a large geographical information system. It offers lots of geographical information, such as precipitation, soil, if there's any protected areas, what's growing there right now, etc. But it has two functions that deal specifically with climate adaptation. First, it allows foresters to assess how well suited specific trees are to a specific site in a changed climate. This is what you see here. On the very left side, a user would select a kind of tree. You have some kinds of oak trees here, kinds of beech trees, etc. Then an anticipated climate change model. You have here current climate. Then next to it, you have a kind of medium climate change that corresponds to RCP 4.5, and strong climate change, which corresponds to RCP 8.5. And then on the map, you would see how well that chosen tree would do under the chosen climate change model in a specific area, with green indicating that tree is well suited to the site, and red indicating, oh no, definitely don't plant that tree here. It has a second function, which assesses which forest development types are suitable to a specific location. Forest development types are specified in the reforestation concept, which is also published and developed by the state. Each forest development type contains a mix of several tree species, which are presented in 4 categories, but each category then contains a long list of trees which fit into that category. So it's able to suggest a very diverse kind of forest, especially when compared to the monocultural spruce forests before. So users then would select also a specific site that's indicated here by this little dark green dot on the left side of the map. They would also select a climate change model, and then the system would suggest which forest development types are suitable. You can see them here by these colorful bubbles in light blue, dark blue, and purple with numbers inside. And each development type corresponds to a type also in the reforestation concept. So the users would have to look it up, and they would see which trees they could plant here. So how do these apps deal with uncertainty? Arguably, Woods app takes uncertainty as the starting point. It makes no prediction and instead offers constant monitoring as an option to deal with uncertainty. If we cannot know what the future brings, the application seems to say, then we have to look constantly, or at least frequently, to see how it's changing. And then we can know what's going on, and we can react right away when changes that we cannot predict occur. Waldinfo seems to rely much more on predictions. Users need to select a predictive model, and then the system makes a further prediction about how specific individual trees would do in that area. So it tries to give some kind of certainty about the future and about of the climate and of forestry. So it's very different from Woods app. But however, the second function of the forest development types adds the aspect of diversification to this. The forest development types are rather diverse and try to support significant diversity of tree species. Diversity is itself here a strategy to deal with uncertainty, as it tries to keep options open or create more options for an unknown future. We don't know what the future brings and which tree will work, the application seems to say, but maybe one or some of these will continue to grow and be able to fulfill the ecological and economic functions of the forest. So what's the main contribution of this paper? It is an outlining of options of socio-technical support for climate change adaptation, While we focus on forestry, other sectors such as agriculture, urban planning, or conservation also have to deal with the effects of the climate catastrophe and the uncertainty it brings. Our paper shows two possible ways to deal with this, which can inspire other HCI work. This adds to, on the one hand, to a discourse on sustainable HCI, but also on knowledge management, which often assumes that appropriate knowledge exists but is not well managed. Our work expands this discourse by asking what is to be done when such appropriate knowledge is absent. Of course, these are only two approaches, and there might be much more, and we look forward to doing further research and hopefully presenting it here. Thank you very much for listening. And at the event, we're open to questions now. Thanks.